Hi everyone. Today we're going to talk about section 11.2, arithmetic sequences. We're going to start with a warm-up that actually takes us back to Algebra 1, Algebra 2, and even the beginning of this year. It says, identify the equation of the line that goes through these points in either point-slope form and slope-intercept form. So let's start with point-slope form. So remember, with point-slope form, we need the slope, which is y2 minus y1 over x2 minus x1. So we're going to plug those numbers in kind of quickly. Subtract the y's, subtract the x's, going in the same order. And that leaves me with 2 over 1, which is 2. Now, I have the slope. I need to choose one of these points. So to do that, let's just pick the first one. We do y minus the y value equals your slope, and then x minus the x value. Okay, now I could have used the other coordinate. I could have done y minus 4 equals 2 times x minus 5. Either of these would have been acceptable. Okay, now if I wanted to rewrite in slope-intercept form, I know that my slope is 2. The problem is I don't know the b value. So I would need to plug in one of the coordinates. Let's plug the first one in. So you put the 2 in for y, the 4 in for x. So we have 8 plus b. Move the 8 over, and you get a b value of -6. That tells us the equation is 2x minus 6. Okay, now the reason why we are spending a little bit of time in the beginning talking about a line is because arithmetic sequences are going to have a little bit of a connection to that, okay? And we're going to learn about that with this next example. So let's go ahead and scoot down to our table. You'll notice we have a sequence here. 10, 15, 20, 25, 30, 35, etc. So our first term is 10. Our second term is 15. And I'm going to fill in the rest. Okay. And that'll take us down to the nth term. Okay. Now, the sequence notation, we write a sub 1. Remember, we write, if this is my first term, we say a sub 1 equals 10, okay? If we were talking about a function, we would say f of 1, f of 2. So we're just making that connection to what we've seen previously. Now I'm going to plot these kind of like ordered pairs, where the term number is on the x-axis. Notice I've got the first term, second term, third term, fourth term, etc. Somehow these kind of fell off the lines, but I'll even it out. I'll actually make sure your copy of the notes is even before I post it. There we go. Okay. The y-axis is the term value. So the actual value of the term a sub 1 is 10, a sub 2 is 15, etc. So let's plot these points. I've got 1, 10, 2, 15, 3, 20. Keep going. Okay, and you'll notice that the pattern that we have is linear. So we have a linear pattern. Okay, now the next thing we're asked to do here is write an equation in point-slope form and slope-intercept form that matches the graph above. Now, if I were to draw a line going through, and I'm not going to do that right now, but I would notice the y-intercept is 5, okay? And then we can find the slope by using our slope formula. So change in y over the change in x. I know some of you guys have faster ways of finding the slope. For example, you would see how much you're increasing your x's, or I'm sorry, increasing your y's would be by 5, as your x's increase by 1. Something like this. I see this all the time with students. So that tells us our slope is 5. Now, if I wanted to write an equation in point slope form, I could, let's say, use our first term. So we've got y minus 10 equals 5 times x minus 1. Okay, and this would be our point slope form. Now, if I wanted slope-intercept form, y equals mx, so we've got 5x, and we can see that our y-intercept is going to be 5, just by extending this pattern until it hits the y-axis. Okay, now the reason why we call this an arithmetic sequence, or the definition of an arithmetic sequence, is a sequence where successive terms, that word successive means one after the next, have a common difference. Okay, so when I say common difference, I want you guys to look at the values between the 6th term and the 5th term. Notice if I were to subtract these two numbers, I get 5. Let's go up to the 3rd term and the 4th term. If I subtract these, 25 minus 20, I get 5. If I go up here, 15 minus 10, subtract them, I get 5. Notice it's a common difference. What that means is you're always adding or subtracting the same number. Add or subtract the same number. And that number is our common difference. Okay, I know a lot of times difference, you're going to picture subtraction. Notice the numbers are getting bigger, but the key is that they're getting bigger by the same amount each time. Okay, so let's jump to the next page. And we have a couple different ways of expressing arithmetic sequences. And let's write the definition down again. We have always adding or subtracting the same value to get successive terms in the sequence. And actually, I want to go back. One thing I forgot to mention. The reason why we didn't connect the dots here, even though they do have a linear pattern, it's not a line, because a line would imply that there are values in between. This is my first term. This is my second term. I don't have any terms in between these two. This is the first one. That's the second. That's the third. That's it. So the numbers in the sequence are the only values that we have. Okay, so that was just the reason why we didn't have a line connecting. I just wanted to clarify that. Okay, so an explicit definition. I'm going to write the formula first, and then we'll talk about what it means. A sub n means your nth term is determined by a sub 1 plus n minus 1 times d. Okay, so a sub 1, what is that? This is the first term. So if you have the sequence, you start your equation with the first term. N is your term number. It's the variable. Okay, it's kind of like having x in an equation. That's going to stay there. Okay. Finally, D is the common difference. Oops. Common difference. So as long as you know the common difference in the first term of a sequence, you can write the explicit definition. Explicit means if I'm looking for the nth term, and I think we covered this in the previous section, if you're looking for the, let's say, 15th term, plug 15 in for n. Okay, that's basically how an explicit definition works. It means if you're looking for a specific term, you just plug that term number in. Okay, now recursive requires the previous term. Okay, so if you, for example, are given the first term, okay, where you know it's some value, whatever that is, the recursive formula, a sub n, is the previous term plus the common difference. So for example, if, and actually let's write this down, this is the previous term. That again is the common difference. Okay, so I'm going to put an example up top. Let's say I have a sequence of, let's call it 1, 3, 5, 7, ... If I'm looking for, let's say, the fourth term, I need to know the previous term. And you guys will notice that the common difference here is 2. We're adding 2 each time. So to find the next term, I would add 2 to the previous term. Okay? Now we're going to do a bunch of examples together, so hopefully it'll start to come together a bit. So first of all, find the first 4 terms and the 32nd term for this sequence. This actually summarizes what we did in our previous section. So let's go ahead and write those out. A1, A2, A3, A4, and then the 32nd term, A of 32. So A1 means we're plugging 1 in for n. Now if I plug 1 in, I have 2 times 1 minus 1 gives me a final value of 1. Our next one, 2 times 2, plugging 2 in, minus 1 gives me 3. Plug 3 in, gives me 5. Plug 4 in, gives me 7. Plug 32 in. 2 times 32 is 64. Minus 1 gives me 63. Okay, so we call this an explicit formula because whatever term we're looking for, we just plug that number in. All right, let's take a look at the next one. Come up with an explicit definition. So let's see what the pattern is. We've got 13, 7, 1. So what's our common difference? Well, notice that we're going down by 6 each time. So we would say that the common difference is 6, negative 6. Okay? Now, our definition, if we're going up to our formula here, up top, starting with the first term, so we've got 13 plus n minus 1 times the common difference. And I am perfectly fine with you guys leaving your final answer like this. Sometimes students will want to distribute. That's fine too. It'll just simplify the equation. But I'm okay with you guys leaving it just like that. Okay. Now we can find the 300th term by plugging 300 in. Now here's where a calculator is going to come in handy. So I've got 13 plus 300 minus 1 times negative 6. Negative 1781 would be our answer. Okay. Now a recursive definition requires us to, first of all, give the first term, which I know is 13. Now, our formula says that you take the previous term, that has to be part of the equation, that's your variable, and put the common difference, so I have plus d. Now, because my common difference is -6, I'm gonna write -6. That tells me, my formula says take whatever previous term, subtract 6, and that'll give you the next term. Okay. Moving on to example 3. So if I want the 4th term, notice that this is a recursive formula. A sub n minus 1 means the previous term. That means in order for me to find the 4th, I need the 3rd. But I don't have the 3rd. So then I need the 2nd. So I'm actually going to start with the 1st term. And I have to find every single term in between. So to find the 2nd one, I'm going to take the previous term and add 4 to it. To find the 3rd term, I'm going to take the previous term and add 4 to it. To find the 4th term, I take the previous term, which is 6, and add 4 to it. And that would be my final answer. So one of the annoying things about recursive formulas is, let's say I wanted a sub 100. You would need every single term up until 100 in order to get that value. Okay, so obviously explicit formulas are a lot easier to use. Okay. Now, sometimes you don't have the first term, and that presents sometimes a bit of an issue. Now, we have the 11th term of a sequence is 63, and the 15th term is 87. We want to find the 100th term. Now, we're going to treat this like a linear equation problem, where I have 2 points. 11 goes with 63. 15 goes with 87. So what we can do here is remember that the common difference is like your slope. So if I were to find the common difference, which is the slope, so do some quick subtraction here. So we have a common difference of 6. That means it's going up by 6 each time. Now, if I were to write out this formula, all I know right now is D. I don't know the first term, and that's a problem. So what I need to do is plug in one of these values. Okay, remember that this is n, this is a sub n. So for example, if I put 63 in for a sub n, I'm going to put 11 in for n. Common difference is 6. And now I can solve for the first term. Let's see, we've got 10 times 6, which is 60. That means my first term, just subtracting, has to be 3. Now, if I were to plug this back into my formula, so let's move over to the left here. I've got a sub n equals 3 plus n minus 1 times 6 is the common difference. That would be our explicit formula. Sometimes you'll be done at this point. But if I want a sub 100, we have to take this 100 and plug it in for n. Now I need my calculator for this. And I get a final answer of 597. Okay, so a bit of work, but we basically treat it like a linear problem. Okay. All right, so our last little section here is talking about finding the sum of a bunch of terms in an arithmetic sequence. So this capital S tells us that we're looking for a sum. S of n means the sum of the first n terms. Okay, so if I want the sum of the first 100 terms, okay, of this sequence, I need to find a few things first. Now, going back to our formula, n is the term number that you're looking for. So we're going to do 100 over 2. Parentheses, a1 is the first term, so I know that one, plus a sub n. Now this a sub n means the nth term. So in this case, I can't use the formula. I'm missing something. I'm missing a sub n. So what we need to do is find, actually let's write this over here. We need the explicit formula first. Okay, so my explicit formula is a sub n is my first term plus n minus 1 times the common difference. So I know the first term. N minus 1. My common difference, we're going up by 2 each time. Now, if I want the 100th term, that's what we're looking for here, I would plug 100 into the formula. All I did was plug 100 in for n. Now when I throw this into my calculator, I get 199. Now that's what's going to get plugged in to our formula. So we've got 100 over 2, 1 plus 199. Okay. Now you can simplify this a bit before you type it into your calculator. Like I know that this first part is 50. 1 plus 199 is obviously 200. And I get a final answer of 10,000. Well, what does that mean? That means if you add up all of these numbers, 1 plus 2, not 2, 1 plus 3 plus 5 plus 7 plus ... all the way up until 199. If I add up all these numbers, I'm going to get 10,000. So it's a lot faster way of us doing that. Okay. Now remember that sigma notation, this means a sum. Sigma, or summation notation, means we've got a sum of, in this case, the first 25 terms. Now, if I'm using my formula, I know I need the first term, I know I need the 25th term, and I know I need n. Those are the 3 variables in my formula. Now, the first term I find by plugging 1 in for I. So if I plug 1 in, I've got 5 times 1 minus 9. That gives me -4. The 25th term, lucky for us, we have a formula right here. It's nice, you could just plug them right in. So plugging these in, we get 116. And n, well, we have 25 terms total. So if I jump to the sum of these 25, I'm going to plug n in over 2. Again, going back to my formula. The first term plus the last term. And now we can throw it into our calculator. So I've got 25 over 2, negative 4 plus 116, 1400. Okay. Always put your box around your final answer so we know which it is. Okay. All right, let's take a look at number 7. The first 50 odd numbers. So let's make a list. We've got 1, 3, 5, ... So I know the first term is 1. I don't know the 50th term. It's not 50, right? Because I'm going up by 2 each time. But I know that there are 50 numbers total. So this is where if you don't know a sub n, you need to use the explicit formula. So let's do that. So my first term is 1 plus n minus 1 times the common difference, which is 2. So if I'm looking for the 50th term, plugging this into my calculator gives me 99. So now I'm able to use the sum formula, n over 2, first term plus the last term. So I have 2,500 as our final answer. Okay, so in this case we were missing the last term, so we had to use the explicit formula to find it. All right, our last one. Find the sum of this series. So my first term is negative 3. My last term is 45. But the problem is, I don't know how many terms there are. So here's another situation where we're missing something. So I'm going to write out my explicit formula. Okay, so a sub n equals, I'm just writing the whole thing out. So my first term is negative 3. I don't know what n is. But I do know the common difference. Well, we're going up by 3 each time. Okay. Now, a sub n, remember, is the term that you're looking for. So I'm trying to figure out which term number is this. So I'm going to put 45 over here. That's a sub n. That's the last term. Okay. So at this point, I'm going to move the 3 over. Divide by 3. Add 1. And we get n equals 17. So that means 45 is the 17th term in the sequence. And now we have enough formula to use our sum formula. Or not enough information for the sum formula. So we want the sum of the first 17 terms. First and last, we're adding them together. And plug it into our calculator. We end up with 357. All right, that's all I have for today. Your homework is posted. Because of the change in schedule this week, our homework is going to be due Wednesday night by midnight. Go ahead and call into office hours if you have any questions, and have a great day.